Students, I welcome you to the lecture number 18, and we are going to discuss here about the model selection, data visualization and data transformation. As you know, in the last 7-8 lectures, I have discussed about different kinds of machine learning models, starting from linear models to complex ANN and clustering. But how do you select a model for your informatics problem? And that depends on various factors. So, today we are going to discuss about that. So, you have seen that this third section of this course has linear models followed by model selection, visualization, transformations. So, that is what we are discussing today in the lecture number 18. So, let me first talk about some recap of what we have learned. We have talked about a very difficult concept called hierarchical clustering in the last lecture, and this is basically a connectivity based clustering problem. Here we can find out groups with connections, or we can measure basically different connections to find out groups. That is the better way of saying that. So, here we create a dendrogram, a tree like structure to represent the connections or relationship between the different groups. So, individual data points are located at the bottom of the dendrogram, which is tree like structure, while largest clusters, which include all the data points, are located at the top. And you have to generate different types of clusters. Dendrogram can be sliced at different heights. Okay. So, first of all, its hierarchical cluster talks about hierarchy of tree like structures. Key idea is to begin with each data points as a own separate cluster, and then progressively merge or split based on their similarity. So, can you imagine there are fruits of different types: apple, banana, cherry and grapes. We can make them as a hierarchy or separate groups, or we can make them as a different grams or weights also. So, this is one such clustering of different subjects. Okay. These are different subjects that sits at the top of this hierarchy. So, you have agriculture, biology, physics, computer science, space. Then are different sub-subjects or classes are kept at the bottom. So, you can slice at any level. Let us say I slice here, okay. I can slice even top also here and create different hierarchies, right. That is the way it is done normally, and basically it is built on a dendrogram like structure, which is nothing but a tree like hierarchical taxonomy, and it forms basically a recursive type and partition led clustering algorithm. This is recursive, right. We are dividing this data from top down. Now, I told you difference between clustering and hierarchical clustering, very simple. In clustering, we are simply making self similar groups based on the distance between the points, and we can calculate the distance as different matrices. In hierarchical clustering, we instead, in addition to that, we have to find out connectivity links. That is why you see that the U1, E3, there are two clusters like U1 and E2. Then EU1 has E4, E3 as two clusters. You can see E4, E3 and E4, right. E2 has E7, E8, correct. You can see that E2, and the total is E, right. So, that is how the clustering is done in hierarchical clusterings. This is distinctly different from the clustering. Here within each of these small circles, we can find out the hierarchies by simply measuring a distance from each other objects. Correct, you can do that. The distance is a matrix. So, therefore, dendrogram is the best way of representing the hierarchies. It is like a family tree of clusters. It shows how different individual points can be connected, a group of points can be connected. Bottom will be having all the data points of its own group. As you move up, similar groups are actually combined That is how it is done. So, there are two types of hierarchical clustering. So, one is called agglomerating clustering, other is called divisive clustering. The name itself suggests what is the type of cluster it is. In agglomerative clustering, it is called a bottom up approach, in which a structure is more informative than the unstructured set of clusters, and this is basically does not require any specification of the number of clusters. So, each data is considered as a singleton clusters at the outset, and then successfully they are agglomerated pairwise. The one I shown you here also, same story, each point was one cluster, here you can see, then they are clusters individually to create hierarchies. Okay, that is how it is done. So, there is no pre-specification number of clusters, it is always similar. So, bottom up algorithm treats each data as a singleton clusters and then successfully agglomerating them to produce the clusters. In case of divisive algorithm, it is a top down approach. It also does not require to specify any number of clusters, but you can split the big cluster into smaller ones to find out the self similarities. Okay, that is how it is done. So, hence this is what is shown here. In case of agglomeration, we start with individual points, you can see P, Q, R, S, T, then based on the self similarity you put together different groups, and finally you build the top clusters. Divisive is exactly opposite, start with top cluster, divide into different groups, finally come down to the elemental singleton clusters. So, that is what is the difference between these two clusters. Agglomerative cluster is more shown here. Here it is basically a bottom up approach, in which you start with all these singleton, each cluster has singleton clusters, then based on self similarity you put B, C together, D together, finally you can put D and F together, and again you put B, C, D, F together, finally A is connected. That is how the different steps, step 1 to step 5 are practiced. And this is the dendrogram. It is basically tree like structures you can see here, point Q, S, R, T all are separated at the bottom. As you move on, P, Q are connected, T, U are connected, then T, U and S are connected, T, U, S are connected, finally all of them are connected. That is how the dendrograms are made. Workflow is very simple, I do not need to explain you again. You can start with individual clusters, calculate the distance between the clusters. It can be simply Euclidean distance or Manhattan distance. Initially, you can actually take each point as a one clusters, then calculate distance between that. Then based on the distance matrix, you can put the closest clusters first, merge them, update the distance further, again repeat this steps 3 and 4 again and again to generate the dendrogram. Divisive clusters is little different, but it is a top down approach. It requires method of splitting the data, not agglomeration, splitting the data, and then it proceeds by recursively splitting data individually, all split into singleton clusters. Okay. So, start with all the data points in the clusters, split the cluster based on 2 smaller cluster or 3 more or more than that clusters, and finally you can find more similar clusters and put them together and repeat this process again and again. Okay. This is what is shown here. You can see this is all the points together and divide into 2 points B, C, D, F and A, and further divide into 2 further point D, E, F and B, C, and then D, E, and then further singleton clusters are made in that way. How do distance you calculate? You can calculate minimum distance between the 2 points. You can calculate maximum distance also, find the maximum distance between the 2 points of the clusters. So, that is also another way, or you can always calculate the group average or Watt's method. So, in this case Watt method is distinctly different. Similar to 2 clusters based on the increase in squared error when the 2 clusters are merged. Okay. So, I just wanted to explain you how it went on. Please read about the hierarchical clustering in detailed manner, because this is something new. It is not like simple clustering problem or k-mean clustering problem. So, how do you select the model or visualize the model or transformation? Okay, that is the question I have to ask. Well, if you look at AI cycle, what do you do first? First thing is you have to, in AI cycle you have to first do is what is known as a problem scoping. Okay, you have to first understand the problem. In the AI cycle, this is suppose AI cycle. So, as a part of this, first you define what is known as a problem scooping. Okay, you can scoop the problem out. This is the first step we do. And when you do that, you have to understand what the problem is, what the physics of the problem is, because selection of model depends on that. Let us say you are talking about a heat transfer problem, okay, or calculating the best material. I gave you an example in the first class, also calculating the best material which is be required for furnace lining. So, that means you need to know the problem statement is related to heat transfer. So, you can bring in that physics and then define the problem. Or if you are talking about a problem of, let us say, strength, you have to find out the material which is having the highest yield strength or best combination of yield strength and ductility. You are talking about a problem of mechanical behavior material. So, your problem definition depends on what kind of problem you are talking about it. That is very important, and that is come under the problem scooping. Next thing is that once you know the problem scooping, you have to do what is known as a data acquisition or data collection. Okay. So, you have to find out the data on that subject, right. If it is a heat transfer problem, you have to find out electrical thermal conductivity, thermal diffusivity, density, all this data required. If you are talking about strength, then you have to find out yield strength, ductility. So, you have to collect all this data. Am I clear? Next, you have to do a data preprocessing, okay, and or what is called data exploration. In data exploration, several things comes into picture. One is called data preprocessing, okay, preprocessing of data, visualization of data, okay. This is the two main aspects of that. And then what you do after that? You do a modeling then. You have to use certain AI models to find out the what is modeling. And lastly, you do evaluation of the model. How good was the model or how bad was the model, that you decide. And I told you in the last lecture, in modeling we never use a single model. We always use multiple models and then find out which one is best for the particular problem. So, this is basically AI cycle. So, first step is problem scooping, right. There I told you, you have to find out what kind of problem you are handling and bring in the physics of the problem, decide what kind of modeling you are going to do. Okay. This is very important, you have to understand that. So, this is the typical AI cycle, and this AI cycle model selection is a very critical step, right, very critical. So, this is the fourth step in the whole AI cycle. So, what do you do that? First step is model selection, understanding the problem and data. So, therefore, in problem scooping, you have to understand the problem. That is why a domain knowledge, understanding the problem. And also data. So, what does it mean actually? That means that before you select any model, it is important to first analyze the problem which you are trying to solve. I told you, right. And this step is to determine whether it is a regression type problem, it is a classification type problem, or it is a clustering type of problem. So, that you have to distinguish from the problem itself, and this is a step which also need your attention to the data, understanding of data, right. The data which you will be using, you have to understand how the data is, what are the quality of the data, all these aspects. Okay. So, that means the objective is to find out the kind of problem which you are going to handle, and this is very important step in the sense that if you are not able to understand the problem, you may land up using model which will not be fitted for this, right. Suppose the problem demands you to use regression analysis and you are using unsupervised learning method like clustering. So, you are not going to get the best answer of this problem. This you need to keep in mind, okay. Then only you can use that. Another important aspect is is that the data set itself, one has to check various part of the data which we will discuss the next part of this today's lecture, data preprocessing, and whether data is numerical or categorical, quality of the data, or many other things which let us discuss about that. So, therefore, the selection of a suitable model is very important, whether it is a regression or in regression is a linear regression, or is it a nonlinear regression, or is it a logistic regression, decision tree, random forest. I have not discussed random forest, but that is a part of decision tree, or you are going to use some other neural network, k-nearest neighbor clustering, or recently I talked about hierarchical clustering, what kind of things you are going to use, that you must have a good idea about the whole stuff. So, this is very critical, that how do you select your model. Okay. So, next step is what is known as a data visualization. What is data visualization? Well, it allows you, this is also a process of understanding your data. Before you actually put the data into model, you can actually visualize data to understand how your data are. So, you can convert the complex data set into visual representations, like you can create graphs, maps, charts, or even different diagrams. Why you do that? Because it enables you understand or get sense the large number of data, amount of data quickly. Because if you have data in terms of table form, you cannot understand the data properly, or you cannot even make a sense out of it. Instead, if you make a plot or a graph, you can quickly understand the data. Sometimes it allows you to understand, identify the trend or relationships also, correct. That allows you to go back to your model selection, whether you have selected a model properly also. Many other confidential information you can provide, whether there are outliers, there are some confidential information like some data are missing or not, many other things you can get it from this. So, visualization is very important in the sense that it allows you to create a better understanding of your data. Second important thing is, this is a part of data exploration. As I told you, data exploration has both preprocessing and visualization. First, we will discuss about the preprocessing. So, choose the type of models that the project can actually solve the problem, and many times you need to preprocess data from the multiple sources also has to be aggregated, and once you do that, the visualization becomes very important, whether the data from other sources are falling in the same domain of your calculations or not. You can plot it and see it also. So, this is very important in the sense of understanding the problem, okay, understanding the problem in terms of doing that. So, let us talk about how data are preprocessed. By the way, before I go into visualization, let me tell you, understanding the problem, there are 4 important things you have to ask question. They are called 4 W, and in the many books it is written as a 4 W's canvas. Okay. What are these 4 W's? These are 4 questions basically. First is who. Okay. That means who are your stakeholders. You are solving a problems, for whom you are solving a problem. What are the who are stakeholders? You may got a problem from industry, you may got a problem from some other source, right. So, this is very important, what they want, what kind of information they want from you. So, this who is very critical. Okay. So, because they are the ones who will be affected by your prediction, not you, because we are solving the problem for them. Second thing is what. What means what? You must make sure what is the nature of the problem is, correct. Can you explain very simply the problem is, like heat transfer problem. If I ask you, if you do not have good knowledge about the heat transfer, Fourier's laws, convection, conduction, how can you explain this problem to a third person? That is what I am talking about it. Okay. So, it is important is what is the problem it is to be understood first. Third thing is called where. in this 4W canvas, in which context or situation this problem needs to be handled. Okay. So, that means it talks about constraint in the problem. Okay. Under what context you are going to solve this problem. And last thing is called why. What is why? Why do you believe it is problem? It is a problem which is worth solving using machine learning or data informatics. It might be solved by any other much simpler approach. So, why to use resources for such a kind of problems? So, this 4W canvas is very critical when you are selecting a problem or handling a problem. So, please understand these aspects very easily, and these tools are available now to understand understand a problem. Do not underestimate that you are the first one who could handle this. Okay. So, now we coming back to data visualization, which is our basically data plotting. What is that? Let me explain you more expansion of that. So, as you know, data visualization allows you to understand the trends and the patterns. Basically, it allows you to quickly identify the patterns, trends, outliers. It allows you to get insight about the organization or how the data organized in a very fast way. Sometimes it also gives you idea about areas of improvement. Okay. So, what are the key performance indices? That also allows you to identify that. It obviously reduces cost of modeling, it reduces the cost of simplifying any complex problem, and lastly it can allow you to understand in-depth understanding of your data. There are a lot of tools which are interactive in nature, which can allow you to understand or explore this kind of data. Okay. I will give you these names of some of the tools which are available on the internet for easily how to understand that. Okay. So, visualization means what? It refers to process of representing the data for visual or graphical representation. Okay. That is the main idea of that. So, you can see there are a lot of free tools available for visualizations. So, Tableau is one such tool which is available from Microsoft. Their names are also Plotly, Microsoft Power BI, Joe Analytics, Kibana, Google Charts all of us use. Microsoft Excel is something which all of you use. Okay. This is taken for Geeks organization, Fusion Charts, Charts.js, many others. These are all free visualization tools which I have taken from Geeks. Okay. There are many other tools which you can buy and do that. So, you do not need to understand that, and these are the different plots which can easily make from that. So, you can see this is a XY plot which allows you to feed the data. These are actually systematic different plots. I have shown pie charts. Okay. This is trend charts, many other kinds of charts possible. This is globe charts, or what is that? This is called something name. It has some name. Let me tell you that. So, what are the names? First, this is called scatter charts. Okay. This is called bubble chart. Yes, this is called bubble charts, and this is line graph. Okay. You can always do that, line graphs. Then you can also have what is that called, pie charts. This is pie. Okay. This is also pie charts. These are bar charts. This is also bar. This is also bar. Okay. Bar charts, and this is, you can also have chloropaths like maps. Okay. Histograms. I have shown you earlier histograms, right? And there are many more charts are possible. Okay. So, there are many ways you can visualize the data. So, therefore, visualization is very, very important, which allows you to understand what kind of data. Like here you can see it allows you to understand the scatter from your things. Bar charts allows you to relative distribution of the aspects. So, in the AI project cycles, the problem solving data collections, data explorations are very important. As a part of data exploration, pre-processing is something we will discuss in the next part of our lecture. So, let me stop here. We will come back and talk more about this data processing